Assalamualaikum dan salam sejahtera kepada Dr. Ahmad. Kami dari grup 3 akan membentangkan chapter 6 iaitu Measurement of Energy. Presenter untuk chapter kali ini ialah saya sendiri, Ajiman dan Durga. So this is our group member. We have Durga, Muhammad FIRDAUS, Muhammad SYUKHRI, MULIANI, me, SITI Ismah dan AHMAD DANIAL. Our presentation outline, which is we have objective, what is measurement of energy, the general type of energy meter, and so on. This is the objective of this presentation. So firstly is to learn the testing method in order to verify the accuracy and reliability of the meters under various load conditions. Secondly is to ensure the energy meter are able to measure the energy consumption correctly. Next is to implement stable and consistent test condition to obtain reliable result. And lastly is to apply phantom or factitious loading arrangement to avoid wastage of power and ensuring efficient and cost-effective testing process. So firstly, what is energy measurement? Energy measurement involves quantifying the amount of electrical energy used over time, and it is typically measured using an energy meter. The energy meter, also known as watt-hour meter. The fundamental principle behind this measurement is the product of power and time. So the process integrates the power consumed at any given moment and sum it over a specific period, and this providing a measure in unit such as kilowatt hour. So this measurement is important for tracking energy consumption and managing electrical load in various settings from residential home to industrial facilities. There are three general types of energy meter, which are electrolytic meter, motor-meter, and clock meter. For the electrolytic meter is used to measure ampere hour or coulomb by using electrolytic action. So this type meter operates exclusively on direct current, as it measures the deposition of metal resulting from current flow in a single direction. So the principle behind this is the electrolytic deposition, where the amount of metal deposited at the electrode is proportional to the current passing through the electrolyte over time. This method is particularly useful for measuring energy consumption in situations where the voltage supply remains constant. By multiplying the meter ampere hour reading by the constant voltage of the loop circuit, one can determine the watt hour. The watt hour is consumed by a load, and additionally, while electrolytic can be adapted to measure kilowatt ampere hour on AC circuit by using rectifier and current transformer, it cannot accurately measure kilowatt hour due to the compilation arising from power factor variation. For the multimeter, a multimeter is instrument used in both DC and AC circuit. Its operation relies on correlation between the rotation speed of the meter rotor and the electrical parameter it measures. For ammeter, the rotor speed directly corresponds to the circuit current, while for watt-hour meter, it reflects the power consumption. The fundamental principle is that the number of the rotor revolution over a given period is proportional to the quantity of electricity or energy supply. This rotation is mechanically translated through a train of wheels connected to the rotor, and this allowing for a direct and accurate registration of ampere hour or kilowatt hour. A clock meter, which functions effectively on both AC and DC system, is used to measure electrical energy with high accuracy. It remains unaffected by external magnetic fields and exhibits minimal error related to the temperature, frequency, and waveform variation. So this ensuring reliable performance even under challenging conditions. This type of meter is particularly accurate for small loads and making it ideal for specialized application where precise measurement is critical. However, due to the complex construction and higher cost, the clock meter are not commonly used as household service meter, where simpler and more cost-effective alternatives are preferred. For the measurement of volt ampere hour, there are two methods of measuring volt ampere hour meter. The first method involves compensating an induction watt-hour meter to accurately measure volt ampere hour. So this is achieved by adjusting the flux in its pressure circuit to lag behind the applied voltage by 90 degree plus pi, where the pi represents the average power factor angle of the load circuit. So when the power factor of the load circuit is exactly cos pi, the meter reads voltage ampere hour directly as VAH equal to integrate VA dt. For other power factor, the meter approximate voltage ampere hour as VAH equal to integrate VA cos theta minus pi dt, where theta is the actual power angle. This method minimizes error, especially when theta minus pi is small. The second method measurement of volt ampere hour is vector addition method. For the principle of vector addition method, this method employs two watt-hour meter elements, which are one measure real power and the other measure reactive power. Their speed are summed vectorially to register the volt ampere hour. So this is formally involved in this method, which is the resultant volt ampere equal to square root watts power of 2 plus force power of 2, while the volt ampere hour equal to integrate square root watts power of 2 plus force power of 2 dt. A trivector method is used for three-phase power system. This method used for measuring and recording a range of electrical parameters including active energy, reactive energy, and apparent energy simultaneously. This versatility allows it to provide comprehensive monitoring and analysis of electrical consumption and efficiency. So this condition making it highly valuable in industrial and commercial application. Before installation of energy meter, it is important to check the meter accuracy. This is important because the error under specified condition must lie within allowed limits. So this is involved prepare all the required approved apparatus for meter testing, which consists of standard apparatus and substantial apparatus. Next, the routine tests to be carried out for all meter at different criteria. So for the apparatus required for meter testing, it consists of standard apparatus and substantial apparatus. So to conduct proper testing of energy meter, standard apparatus such as DC potentiometer calibrated by the National Physical Laboratory for precise voltage measurement, alongside a ship chronometer or pendulum type clock serving as a reliable time standard. Additionally, substantial equipment such as ammeter for current measurement, voltmeter for voltage assessment, indicating what meter to gauge power consumption, or rotating meter likely measuring RPM, and electrolytic ampere hour meter for quantifying total electricity usage.
After preparing all the required apparatus, the routine test is carried out. So for the routine test, the first one will be the low current load test, where for the DC meters which is less than 10 ampere ratings are tested at 10% of their marked current. And for the AC meters and DC meters more than 10 ampere rating are tested at 5% of their marked current. Then the next one is the intermediate current load, where it is tested between the minimum and maximum specified limits. The third one will be high current load testing, where it's tested at maximum rated current specified for the meter. And for AC meter test, the performance of the marked voltage, marked current and 0.5 power lagging are checked. For additional checking, creep test is carried out by applying 110% of its marked value of voltage to the pressure coil circuit of the meter, and it is ensured that the circuit is open for current and it does not complete more than one revolution. There are three methods of testing energy meters, which are method A, long period dial test, method B, which is short period test using a rotating substandard, and method C, which is short period test using a standard wattmeter. As for the long period dial test, the setup of the apparatus are as a substandard rotating meter is used to compare the readings. So first, the current coil of the test meter and a substandard meter is connected in series with the load circuit, and the voltage circuits of both meters are connected in parallel across the supply circuit. And for the procedure of this period test is start both meters at the same time, and after a suitable time interval stop both meters at the same time as well, and ensure the test duration is long enough to make sure that the register of the test meter is it has completed 10 revolution of the pointer on its lowest reading dial. To calculate the error of the meter under test, we use the percentage of error of both the test meter and the substandard meter reading. The advantage of this test is it has accurate dial readings, it eliminates error, and it's flexible load. And its disadvantage is it takes a long time for a single accurate test, and it's not suitable for tests where meter adjustment is needed during the testing. The next method, method B, is short period test using a rotating substandard. As for the setup of the apparatus, the substandard rotating meter of precision type is used to measure the energy passing through the meter under test for a stated number of revolution. And to ensure the scale of the standard meter's largest dial is subdivided to read 1 per hundredths of the revolution. So the setup must enable both the standard and the test meter to be started and stopped at the same time. The lowest reading point can be reset to 0 whenever we need to. So before looking at the procedure, the pre-test condition is the meters must be connected to the circuit with a full load for 15 to 30 minutes to attain steady state temperature before testing. So the procedure will be adjust the load to the required value, then allow the meter under test to complete a specified number of revolutions. Example, let's say we set to 10, so we must wait until 10 revolutions are completed. Then observe and record the number of revolutions made by the standard meter. To calculate the error of the meter under test, the constants of both meters are the same, like you don't have to change anything. If the constants differ, use the formula as per stated here according to what values changed. The advantage is it's less time consuming compared to the previous method because it eliminates error due to starting and stopping of the substandard meter or stopwatch, and no need to keep the load constant, like it can vary. And for the disadvantage, it's not suitable for continuous adjustment during testing. The third method is short period test using a standard wattmeter. So the setup of the apparatus is the precision grade is used to indicate instrument as the standard of the reference, and connect these instruments in the circuit with the meter under test. So before looking at the procedure, the pre-test conditioning is energize the voltage circuit of the meter for at least 1 hour before starting the test. So this must be done before conducting this method to test the error. The procedure is Measure the time taken by the rotor disc of the meter under test to complete 3 revolutions or enough revolutions to make the period last for at least 100 seconds. And then maintain the constant current and voltage during the test, possibly using an automatic stabilizer. So we don't have to monitor that, it will automatically stabilize. And for the calculation of error of the meter under test, this is the formula, we can use it. The advantage of this method is higher accuracy of standard wattmeter compared to the rotating standards, and the disadvantages is it requires greater skill from the tester. The load must be kept absolutely constant during the test, like it can't vary, or else the test results will not be accurate. So when phantom or fictitious loads method is used, so when testing high capacity meters, the normal setup can waste a lot of power. So instead of using the other method, we use phantom or fictitious loading method, which is where the meter's voltage circuit is connected to a normal voltage source, while its current circuit is connected to a low voltage source. So this setup only requires a small amount of power, which is enough for the voltage coil at normal voltage and the current coil at low voltage. So the high capacity meters are tested and their voltage circuit is connected as usual, but their current circuit is disconnected from the consumer's load and they connected to a low voltage source instead. So under phantom loading conditions, the total power required for the test will be the sum of power loss in pressure coil and current coil. So this is the formula, and since the resistance of the pressure coil is very high, the voltage of the pressure coil is very low when compared to the rated voltage of the meter. Therefore, total power required for the test under phantom loading will be very less. Next, to test the AC meters, there are two types, which are single phase meter testing and polyphase meter testing. For single phase meter testing, the requirements are the variation of voltage and current and the variation of phase angle between voltage and current. So for the setup, the voltage source is connected to the pressure coil circuits of the meter. The current source is connected to the current coil circuit. The phase shifting device is adjusted according to the phase angle between the voltage and the current. And for the measurement instrument, the standard wattmeter is used for load measurement and timer for timing the revolutions of the meter under test. So the method is, for fictitious load method, it utilizes a phase shifting transformer to vary the phase angle. It is ensured that the supply is either 2-phase or 3-phase to create a rotating field. For single phase supply, a single phase shifting device is used. So for phase shifting transformer, the rotor of the phase shifter is rotated to change the induced current phase, and the angle to set is adjusted between voltage and the current. The diagram below shows the connection or the apparatus setup to test of single phase meters. The second one is polyphase meter testing, where the requirement is which is similar to single phase earlier, but it involves multiple phases. So the setup of the apparatus goes like: voltage alternator is connected to the pressure coil circuits, and the current alternator is connected to the current coil, and the phase adjustment is where the rotate the stator of the current alternator to adjust the phase angle. For measurement of the instrument, standard wattmeter is used for load measurement and timer for timing the revolutions, just like earlier. And the method is using two alternators, where one alternator supplies the voltage to the meter and the other alternator supplies the current to the meter. Adjust the phase angle by rotating the stator of the current supplying alternator, just by stated as in the setup earlier. And a worm wheel and a graduated circular scale is used to set the precise angle. And the diagram shown is the connection for testing of 3-phase energy meters. The advantage of testing of AC meter is, first, the precision in phase adjustment as it allows for precise control over the phase angle between voltage and current, which is important for accurate testing of power meters. The second one is ease of automation, as the phase shifting devices and controlled alternators can be easily integrated into automated testing system. The third one is reduced power waste, because fictitious load and the phase shifting devices reduce the power needed, so it doesn't waste by using additional power compared to the actual resistive, inductive and the capacitive loads. As for the disadvantages, the first one is complexity of the setup. As we saw the diagrams earlier, both the setups are complicated as it involves phase shifting transformers and alternators, which can be complex in connection, and it needs skilled person to operate it. The second one is potential for measurement errors, because there are some criteria which has to be met, like it has to be started at the same time and it has to be turned off at the same time, so its calibration can lead to errors in meter testing results. The third disadvantage is maintenance. These systems require regular maintenance and calibration to ensure its accuracy and reliability. The key considerations are the accuracy. The precise adjustment is ensured of the phase angle to avoid measurement errors. The load management is where the fictitious load is used to avoid power wastage and to reduce the need to use expensive apparatus. And the third key consideration is instrumentation, where it's reliable and calibrated instruments are essential for accurate testing and comparison. As for the error calculation, the number of revolutions are recorded, which is made by the meter under the test given, and the measuring actual load, use standard wattmeter to measure actual load during the test. The theoretical number of revolutions is calculated by the meter should be made based on the actual load measured by the standard wattmeter, and there are several formulas to calculate the error, but this is the formula to calculate error for the AC meter testing. Thank you for listening, and that's all from me and Ajiman for today from Group 3. Thank you.